Before we dive in, make sure you subscribe to Strange and Curious Planet, where we explore the science, secrets, and strange forces shaping our world. Today's topic sounds like science fiction, but it's 100% real. Deep within the rhythms of our planet lies a cosmic clock that has been ticking for millions of years, quietly dictating Earth's climate, ice ages, and even the fate of civilization. It's called the Milankovitch Cycle, and according to scientists, this ancient system is starting to shift again. Imagine the Earth as a spinning top, tilted, wobbling, and slowly changing its orbit around the Sun. Over tens of thousands of years, these subtle movements dramatically alter how much sunlight our planet receives, not just overall, but at specific latitudes and seasons. That's what Serbian scientist Milutin Milankovitch discovered in the early 20th century, that the ice ages weren't random at all. They were part of a repeating, predictable pattern driven by celestial geometry. There are three key cycles at play, each like a gear in a massive cosmic clock. Together they determine whether our planet basks in warmth or plunges into a deep freeze. First up is eccentricity, which describes how circular or oval Earth's orbit is around the Sun. Over about 100,000 years, our orbit slowly changes shape, sometimes nearly circular, sometimes slightly stretched like an ellipse. When the orbit is more elliptical, Earth spends part of the year farther from the Sun, leading to colder, longer winters in one hemisphere. This tiny variation in solar distance, only a few %, might not sound like much, but it's enough to shift global climate over millennia. Eccentricity is often considered the master cycle that sets the rhythm of ice ages. Next is obliquity, the tilt of Earth's axis, currently about 23.5 degrees. This tilt is what gives us seasons, but it doesn't stay constant. Over a 41,000-year cycle, Earth's tilt oscillates between about 22 and 24.5 degrees. So, a greater tilt means more extreme seasons, hotter summers and colder winters. On the other hand, a smaller tilt brings milder, more uniform temperatures year-round. When the tilt decreases, snow and ice that form in winter are less likely to melt during cooler summers, a recipe for growing glaciers. The last few ice ages align almost perfectly with these tilt changes, showing just how powerful this slow-motion wobble truly is. Finally, there's precession, the gradual wobble of Earth's rotation axis, like a spinning top slowing down. This cycle takes about 26,000 years to complete. So, here's an interesting bit. Precession shifts the timing of the seasons in relation to Earth's orbit. At the moment, the Northern Hemisphere experiences summer when Earth is farthest from the Sun, which, slightly weakens the seasonal contrast. But, you see, in 13,000 years, that relationship will flip, giving the Northern Hemisphere scorching summers and freezing winters. This slow wobble can, amplify or dampen the effects of the other two cycles, making it one of the trickiest factors in predicting future climate trends. Now, when Milankovitch calculated how these three cycles align, he discovered something quite extraordinary. Every time the cycles combined in a particular way, massive ice sheets spread across the continents. Fascinating, isn't it? And when they shifted again, the ice melted, giving rise to warmer interglacial periods, like the one we're living in right now. According to geological records, the last major ice age ended about 11,700 years ago, marking the start of the Holocene epoch, the relatively stable climate that allowed agriculture and human civilization to flourish. But here's the twist. The same cycles that ended that ice age are still ticking, and they're slowly turning toward another cooling phase. You might be wondering, are we due for another ice age? The answer is complicated. Based on the Milankovitch model, the next natural ice age should begin in about 50,000 years, when the cycles align to favor cooler summers in the Northern Hemisphere. However, human activity has thrown a wrench into the cosmic gears. The rapid rise of greenhouse gases, carbon dioxide, methane, and others, has trapped heat in the atmosphere at a pace the Milankovitch cycles just can't offset. Some scientists believe we've effectively paused the next ice age, delaying it for tens of thousands of years. In other words, the same planet that once obeyed cosmic rhythms now, well, dances to humanity's tune. Even with our influence, the Milankovitch cycles never stop. They're the silent heartbeat of Earth, slow, relentless, and powerful beyond imagination. Long after humanity's machines fall silent, the tilt, wobble, and orbit will keep reshaping the planet's destiny, ushering in new ice ages and warm periods as they have for, millions of years. So the next time you feel a summer heatwave or watch a glacier melt, just remember, it's all part of an ancient cosmic dance, one that connects our fragile world to the vast rhythmic clockwork of the universe. And if you want to keep exploring the strange forces that shape our planet's past, present and future, subscribe to Strange and Curious Planet, where the mysteries of Earth are really just the beginning.